Today, we're going to do a little tutorial on using Vectric's v12, either Aspire or VCarve Pro or VCarve desktop tools to trace vector drawings. There's been a lot of discussion on the Vectric forum and on some of the Facebook groups and other places about the missing curve tool and how that's causing people a lot of problems with tracing their drawings. I was not a big fan of that curve tool to begin with, and I've always done it using techniques that I'm going to talk about today that I've learned over literally several decades of 2D vector drawing and then CAD modeling from dozens and dozens of professionals, both in the illustration field as well as the CAD modeling field. So let's jump right in. First, let's take a look at Aspire 11.5 and its predecessor. There was this tool called Draw Curve, which, as you can see now over here on V12, is missing. So what do? You can't just throw your hands up in the air and say, oh, gee, I can't draw curves. There is actually, at least for me, my workflow, there's a much more practical and a faster way of tracing bitmap drawings to create vectors. I should also caveat this by saying, I don't only use tracing to create vectors that I then use in Aspire to create components or 3D models. I also use tracing in a lot of other areas of my professional and my personal creative life for creating 3D models that I 3D print, for creating models that I machine in steel, aluminum, brass, and Delrin, and for copying 3D objects that I think are interesting and I want to model in some way. And this particular workflow will work across all of those domains. Let's start with the background and some observations. The goal of vector tracing should be to minimize the number of anchor points or nodes in order to allow the underlying math to create the smoothest curves possible but trace the image's edge. And we'll touch on why that's important in just a couple of seconds. In general, I've found that people have a tendency to place way too many points to define an outline curve, and they end up with overly constrained vector images that turn out to be more difficult to manipulate and refine, especially if there's symmetry in the drawing, say bilateral symmetry like a butterfly with a wing on the left and the wing on the right that you want to be identical. That's just a simple example. There are more complex examples. And of course, biggie, and this one's a little difficult to put a finger on, and I actually tried to develop some drawings that would illustrate this problem. I've seen it on rare occasions, but by over constraining the 2D image, when your modeling tool, in this case, Aspire, creates the 3D component of it, those constraints can introduce artifacts in your model. Those artifacts can be things like odd crease lines. They could be things like bizarre little twists, things like that in your model. I found it to be more of a problem in tools like Blender and RhinoCAD, which I use a lot. The modeling tools for creating 3D components in Aspire seem to be a little more resilient to this, but in theory, there is that possibility. The other thing is there are very few tutorials out there on how do you actually go about tracing a bitmap image. The old V11 curve tool that we just took a look at really lulled users into placing way too many anchor points. The professionals, especially those that are doing 2D tracing to ultimately create 3D models that I've had the pleasure of working with and getting to know, use a simple set of principles to create the most precise vector tracings with as few anchor points as possible. Their method is also very time efficient once you learn to think in vectors. Every node in a 2D vector constrains the conversion to the 3D shape. And like I mentioned, some of these odd artifacts can be introduced. So they tend to use these very simple principles to help minimize those artifacts. So what are the principles? Well, here they are. Firstly, minimize the number of anchor points or nodes that you place on the drawing. Do an initial tracing pass using straight line segments. And this is where the line segment tool in Aspire and VCarve Pro that I've used for several releases now really was quite useful because that's basically what it does. You go over the drawing, put down straight line segments, and then, as we'll see, we manipulate those line segments into curves to match the actual curve profile of your bitmap. A couple of points on this tracing pass. Firstly, you only place one point at each end of a straight line segment. if you're defining a straight line, all you need is the start point and the end point. And this is where, when you see people using the old 11.5 curve tool, they get into a little bit of click mania. And even on a straight line, they'll place multiple points along the length of that line. And it makes it very difficult to maintain that line as a perfectly straight line. So only place one point at the beginning and one at the end of each straight segment. The second point here is the one that's maybe a little bit more difficult to conceptualize, but hopefully when you see it in the demo, you'll see exactly what I'm talking about and why it's a powerful technique. And that is, for each symmetrical curve, you want to place what is called a chord. A little difficult to see until we actually do the demo, but you'll see what I mean by chord and also why this is a powerful technique. And then the third one, and you really don't see this discussed much, there is a really great tutorial on the Rhino CAD YouTube channel on the use of the rule of 3 to define sharp corners where they're necessary. And I'll go into some detail on that because I think it's really important. And corners and sharp transitions are places where novice users in particular, but even long-term users, tend to really place a lot of unnecessary points that then end up constraining the drawing, making it much more difficult to edit, and certainly can result in minor little kinks in the vector. And then finally, you want to do a refining task to convert all of the straight line segments that you just drew into the curve nodes where they're needed, and use the curve nodes handles to create a curve that matches the underlying drawing. And of course, you can tweak the position of the node itself on the underlying drawing to more precisely position it. I'll demonstrate that. And then you add any additional anchor points only where they're needed, and you remove anchor points that are not needed. But there are a couple of little tips that you can use. The first one, and probably the biggest one, is memorize and use this set of 6 simple keyboard shortcuts to streamline the process. The first set are simply the S, the N, and the M keys to select the different vector editing cursors. S selects the selection cursor. The N, or node editing cursor, is going to be the one we use primarily to do the node editing. The M, or move or transform cursor, is the one that you use to actually move the vector drawing around. Then for the node editing cursor, there are 3 more key commands that are very useful. That is the S to make a point a smooth point, and we're going to be using that a lot. The D to delete a point, and the I to insert a point. With those 3 simple key commands in node editing mode, you can fly through creating a vector image from a 2D bitmap. It should be mentioned that all of these node editing tools are available in the context menu when you hover the node edit cursor over a node or a point on the vector. And there are a number of other tools available there, like a join curve, break a curve, and things like that. But we're not really going to go into that too much. And then another little tip is to turn off geometry and smart snapping. And these 2 icons you'll see at the upper right-hand corner of your V12 display. So they're right there, kind of top and center. Just click on it and disable each of them. And that'll make your life a lot easier because points will go precisely where you put them on the underlying drawing. There is one other little tip that I should probably add to this list, and that is under the edit menu, and I'll just go over here and take a look at it. Under the edit menu, a curve fit vectors, which is a really powerful tool. And even if you do have click mania using the old fashioned curve tool, you can use this curve fit vectors to greatly simplify the drawing. It's not perfect, but it does do a pretty decent job of simplifying and fitting the minimal number of nodes to a curve to get a nice curved vector. And I'll demonstrate this when we get into it. Okay, so now let's just jump right into a demo. I prepared this bitmap image really just to illustrate a couple of key concepts and to show how this whole process of creating curves using the polygon tool really works. So first, let's click that and select that polygon tool. Also, let's go ahead and disable our node editing and our smart toggle editing. And so we're all set to go. And as you can see, I've got the polygon tool selected. Well, to draw a simple square, pretty simple. I'm just going to zoom in so you can see a little bit more. You're basically just going to position on each of the 4 corners. Boom, boom, boom. press tab to close the current polygon. So I click tab, and now you'll see the polygon is closed. And you'll notice that it's orange. That's because I had already created a tracing demo vectors layer, and I set the color as that orange. So it's a little bit easier for me to see and for you to see. So there we go. That is the first tracing. And now if we go into the node edit mode by pushing the in key, we will see that there are only 4 nodes that define the square. Kind of what you would expect, right? So now let's take something a little bit more interesting and more complex. There's a circle. In the curve tool, the tendency is just to go along the outline of this curve and click, 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 and put down who knows how many nodes, several dozen, most likely. In this technique, you only need 4. And it really doesn't matter where you start, but it's conceptually, I think, a little bit easier to start on the quadrants of the circle. So we're going to put 1 point here. Going to come up here and put another point. Going to come down here, put another point, third point here, and then we're going to close with that tab key again. And now you'll see I've got kind of a diamond inside of this circle, but it doesn't look anything like a circle, you say. So how do we fix that? Go into node editing mode, and here we go. Now I could position the mouse cursor over each of the nodes and either do the right mouse click context menu to select the smooth point, or you can just click the S key, which I just did, and you'll see that one just converted to a smooth curve. I'm going to undo that. But another little time-saving trick is you can actually just select all of these nodes, and then you can either use the context menu to change them or just push the S key. And now, boom, all 4 of those points have been converted into curve nodes. And all of a sudden you see, wow, this looks a lot more like a circle. And it's actually pretty straightforward visually on how you would finish making it a circle. You simply use these handles, and I grab and drag this handle out until the curve kind of approximates there. And you'll see that there's kind of this little overlap or this little gap here. That's because this handle at top is angled slightly. So if you position it so it's straight across, oops, horizontal, I mean, well, just do it from this side. I just need to select that one handle, not all of them. For some reason, it was selected all of them. Yeah, there you go. We can just tweak this one a little bit. Now, one thing you'll notice as you make the handle longer, it kind of has the effect of pushing the curve out to the center of where that point is defined and where the point at the other end is defined. But as you make it shorter, it lessens the arc of the curve. So that's how you basically get the curve to fit the underlying drawing. You can just pull and tweak these handles until you get exactly what you need. And you can see that, even me talking and trying to do this, I can very quickly go through and define a circle using only 4 points. This one up here looks a little bit funky, but hey, what the heck? Let's just clean it up a little bit. So we defined a circle with 4 points and have a pretty nice circle. We see this point is not quite on the line, so we can just move it over and tweak it a little bit. And, we're done. Okay, so that is a simple use of this technique to define a circle. Now let's take something a little bit more complex. And this is actually going to be used to help illustrate the rule of 3. And here we have kind of a mishmash of a bunch of different features that you might come across in a drawing. We've got a fairly sharp but rounded corner over here. We have a more gradual corner here. We have a very gradual corner here, and then we have kind of an odd asymmetrical corner. Basically, what the rule of 3 says is you only need 3 points to find a corner, whether it's a 90-degree corner, or a 120-degree corner, any sort of abrupt transition from one path to another, you can define with 3 points. And those points are right at the beginning or the entry point to it, somewhere in the middle of it, and then at the very end. That's it. And you can see line segments there kind of mimic that curve. And as we'll see, we can tweak it later. When we get over here to the sharp corner, same thing, rule of 3, except now the beginning point is going to be right up close to that curve. And then you got your little point halfway around the arc, and then the final one down here. The big sweeping arc right here, the entry point, kind of halfway around. And then the exit point And then over here, let's the entry point. And because this is kind of asymmetrical, we're probably going to select a point somewhere right in here and then the exit point. And then I can just close up with tab key. Okay, so now we've got a rough approximation. Let's push the N key to go into node editing mode and we can see the nodes there. Let's select all of them and push the S key to turn them into curve nodes or smooth nodes, and we'll see what's going on. So firstly, we see we have a straight line across here, but this line segment has been converted into a curve. To do that, as we saw before, we can just drag the handles down. And this is why there's a rule of three. Let's just kind of zoom in on this one a little bit. You notice this handle here is pegged by that node right there for the most part. As I move that handle up and down, there's not a whole lot of action going on over here. And in fact, if I pull this handle all the way over here, now when I change this node, there's virtually nothing. It actually becomes kind of a pivot point. And so that's what the rule of three is all about, is defining those pivot points. So you isolate one part of the drawing from this area where there's a rapid transition in the other part of the drawing. And while we're here, we may as well just go ahead and do the same thing down here. And then we can go over here. Let's zoom in on this little curve. And we can see it's kind of a little bit funky. So we'll just kind of clean that up a little bit. And then down here, we've got another situation where this handle needs to be parallel with the straight line segment. We kind of got it right first time here, which is great. Let's get this one over here. So that part of the curve now becomes linear. And then we see here where we have sort of this asymmetric curve, why I chose to put a point over here where the radius starts to get tighter. And I kind of nailed it first time. All we have to do is pull this handle over here, get the straight line, and we have a nice curve that mimics what's going on there. If I had, for instance, put this node down here, probably no amount of tweaking is going to get this to look exactly right. You might be able to get it, but it's going to be a little bit more difficult. You can make your life a lot easier if you just kind of recognize where these transitions from one particular curve radius to another occur and put your points, your nodes there so you can get it closer to the end result. Okay, so let's just zoom out and take a look at that one. And you can see it matches pretty well. And even with all the talking and demonstrating and whatnot, I was able to very quickly and very precisely with a really small set of nodes represent this curve. While we're on this one, let's go ahead and take a look at that curve fit vectors command under the edit menu. It'll bring up this little curve fit vectors. Use the Bezier curve. It gives you the most mathematically precise representation of the curve. Tolerance, I usually just leave it at the default of 1/100th of an inch. We're not keeping any sharp corners because there are little curves in all the corners here. Replace selected vectors. If you want to keep the selected vector, you can uncheck that. And then nothing is going to happen until you click preview. So I'm going to click preview and watch what happens to the nodes over there. You'll see that it did do some minor tweaks. It actually moved this one down here. It eliminated the point up here on the third, but you see the line doesn't follow as precisely as I did before. And it did eliminate a point down here, but it put a point in up here, which is kind of odd. And it didn't muck too much with this down here. In fact, if we cancel, we can actually see it'll go back to the original form, go into node edit mode. Just something to play around with. You might find that the curves become a little smoother when you do that. But in this case, I think it actually made things a little bit worse. So I wouldn't use it. Okay, now let's take a look at a little more complex situation. And in this one, we've got a combination of some sweeping radii, but we also have kind of a convex curve here that I can use to demonstrate the concept of a chord. And so the curve basically has this chord defined across it, and it's symmetrical or reasonably symmetrical. An asymmetrical example would look something like this. Let's say that I started here and then just went down to here. You can see that that's asymmetrical. So let's go ahead and finish this guy off. I'm going to create a chord, and then I could use the rule of 3 here, but since this is a very large, gentle curve, I'm just going to use 2 points across. Again, you can see the chord there. It's nice and symmetrical. I'm going to go down here and draw a straight line. So there's one point of the straight line. Here's the second point of the straight line at the entry point where it goes into the curved area of the corner. And again, I'm just going to use 2 points to define that area because it's a nice gradual symmetrical curve. Same thing, straight line, endpoint here, come up here, come up here. And then here you can see this is kind of a little bit asymmetrical. So let's go ahead and do the 3-point rule here. So I've got 1 point, I've got the other point up here that's exited. You can see this part of the curve here is a little bit tighter radius than this part up here. So I'm going to put that 3rd point right here and then push Tab key to close up the polygon. We'll go into node edit mode. We're going to select all the curves here. Click the S key to make it smooth. And now we can go about quickly doing the final tweaking to model this. First thing I like to do is just go around and get all my straight line segments defined because those are easy and they're constrained. Boom, boom, boom. We're done. Up here, you see that no matter what you do, you could maybe, but probably not going to be able to represent that curve with just dragging and manipulating the handles. So what we can actually do here is insert an additional point. So I'll just position the mouse over the curve and click the I key. And we see that there's a point that's been inserted. I can then grab that, drag it down here. And now I can just use my handles to manipulate that curve to get it exactly where I want it and follow the underlying drawing very precisely. And down here, we want to lengthen this handle. Lengthen this handle a little bit. You might want to tweak that handle just a wee bit. And there you go. Whoops, that's still just not quite right there. So let's just bring this guy down. We might want to move that point over just a wee bit. And so there we go. So, that's a little more complex with concave curves. So you can kind of see what's going on there and what I mean by chord. And now let's take a look at the last of the simple examples. And that's this shape, kind of a kidney shape with concave and convex curves. Kind of interesting transitions for different radii of the curves. And let's see how quickly we can do this. I usually gravitate to finding a straight line segment and clicking on the initial point of that straight line segment. It's just something that's happened over the years. But as we can see, it actually isn't straight, although it looked straight to me. Here's a chord across that curve. Here's a chord across that curve. Here's a chord across that curve. Chord across that curve. So if I went over here, that's not a symmetrical chord. Let's just drag it down until it's kind of symmetrical. And that's kind of symmetrical. And you really don't even need to be that persnickety about all of this. But the more persnickety you are, usually the better results you get, or if not better, at least the faster you can do this. So now we're close to the end. I click the Tab key to close everything up. In to go into node edit mode. Let's select them all. S key to smooth everything. And you can see, wow, just right off the box, we're pretty darn close converting all those straight line segments into very good representation of this organic shape. But let's just go ahead and finish it off. And that's all done. And this one we can move down here. This is all looking good down here. We'll pull this one around there. This one can go a little bit longer here. And yeah, wow, that happened very, very quickly. And you can see really small number of points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15 points. Probably could have even done it in fewer than that. But, the point is that this vector drawing that we just did is not riddled with dozens and dozens of points that are going to make it much more difficult to work with if we wanted to modify it anyway in the future. So there we have it. That is how you go about using the polyline tool for very quickly creating tracings of bitmaps with all different sorts of radii and corner and convex and concave curve features. So that's pretty much it. It took me way longer to talk through and describe this than it would if I were just going through it for my own purposes. With just a little bit of practice using this polygon tool in the ways and the techniques I just described to very precisely fit a vector around a bitmap image is very efficient, and it generates a vector with a minimal number of node points. So they're much easier to manipulate and maintain throughout the rest of your creative design process. So hopefully you learned a few things, and I'm happy to answer any questions or participate in any meaningful discussion in the comments section below. Thank you very much.